Missing value. How do we check the missing values? Here missing values can be done in two ways. Missing values can be checked for the two variables, one for the numerical variables, other for character variables. One is for the numerical variables and other one for the character variables. How do we check for the numerical variables? How do we check the missing values for the character variables? First of all, how do we calculate whether a particular variable is having the missing values or not? How do we check whether a particular variable is having the missing values or not? So simple, we have one function is.na of dataset $variable name is xyz. So by using this function, by using is.na dataset $xyz, we will get to know how many missing values are presented in the given data set. Is.na, it will give us the true and false. True means particular record is a missing record. False means the record is populated with some number or some character or some value. Is.na will give us the true and false condition. True means particular record is missing. False means every record if it is a false, the record has been populated. The record has been populated. Here in this case, how do we check? For example, let me open the RStudio first. In this case, here in this case RStudio, let me import the one data set, which is, for example, the data set will be unbilled data set. Here this is the data set, is the unbilled data set. Just we are importing the data set into R2. The data set which consists of 35,375 observations along with 11 variables. The data set which consists of 35,375 observations along with the 11 variables. Here in this case, what we are going to do, here first we are going to check the analysis about unbilled data. Here in this case, first what we are checking, dim function of unbilled data. What does it will give? It will give us the how many number of rows as well as how many number of columns. For example, we would like to check missing values. How to check? For example, sum, that means total count of missing values, is.na unbilled data $voice attempt. In the voice attempt, there are 34,418 missing values are there. Out of how many records? Out of how many records we have? These many records we have missing values. Out of 35,375, 34,418 records which are missing value. What is the percentage of the missing value? How many number of records which are missing divided by total number of records. Can we do like this? Divided by dim of unbilled data of 1. So what is the percentage of the missing? 97.29. So out of 100%, 97% of the voice attempt data is missing. So what we need to do? How do we do? How do we treat the missing values for both numerical variable as well as the character variable? Here in this case, what we are going to discuss about, first let's have a discussion about the character variable, then we will go for discussion about the numerical variable. Character variable, character variable is missing. If missing value percentage is less than or equal to 10%, for example 97% like we saw it now, the same way if the missing value percentage less than or equal to 10 percentage, let's now less than or equal to 10 percentage of the missing, then we need to replace with mode value. Less than or equal to 10%, we need to replace with the mode. Wherever we have the missing, those value we need to replace the mode. What do you mean by mode? Mode is nothing but the data point which is repeating more number of the data point which is repeating more number of times is called as the mode. The data point which is repeating more number of times is called as the mode. Next, for example, if it is in between 10 to 50%, 10% to 50%, then we need to replace with missing. Wherever we have missing, just we need to write missing only. Missing only. If it is a 10 to 50%, then we need to replace with missing only. No. Less than 10% is mode. If it is 10 to 50%, then we need to replace with missing. Wherever we have a missing is the number of record, those records we are replaced with missing indicator only. Now here the next case will be greater than 50% up to 100%. Ideally general cases what they will do up to 80% of the cases. Greater than 50%, then we need to create separate flag, create a separate flag. Separate flag means wherever it is a missing, for example, wherever it is missing, whenever it is missing, then 1, otherwise 0, because the reason is that then otherwise 0, then remove the original if it is greater than 50% and 80%, then we need to create a separate flag. Whenever it is missing, then 1, otherwise 0. Then remove the original variable. Why we need to create the 1 or 0 flag? The reason behind, half of the greater than 50% is missing. That means half of the data is missing. Yes, half of the data is missing. In this case, if you would like to analyze, also it will be really difficult. You cannot come up with the half of the information because more than half of the information is missing. You left with the only half of the data. You cannot come to the conclusion about a variable by using the half of the information. Instead of getting the conclusion by using the half of the information, then what we can do, we can create a separate flag. Wherever it is missing, then it will be 1, otherwise it will be the 0. Some cases, if it is greater than 80% of the missing, greater than 80% of the missing, straight away remove the variable. But generally these days people are not following this method. Greater than 80 also they are replacing the values. This is the old tradition, but ideally you have to follow as per the textbooks, but people are not following the same. Even if it is a greater than 80%, still they are replacing the values. But I mean replacing the separate flag only, 1 or 0. Ideally they should have to remove as per the textbook, but they are not removing it. So if I summarize overall view about the missing values for the categorical data, we can simply say the 3 things. Summary basically. What we will say, I mean less than or equal to 10%, replace with mode value. If it is 10 to 50%, replace with missing category. Greater than 50%, then create a separate flag by using 1 as missing and 0 as non-missing. Create a separate flag by using 1 as the missing and 0 as the non-missing. Okay, that is how we will do. And any questions guys about the character data? Any questions? Now let's talk about the numerical value missing. Numerical value less than or equal to 10%, then we need to replace with mean value. If someone asks interview, how do we treat the missing values, then you have to say these methods for both character variable as well as numerical variable. If it is 10 to 50%, then we need to replace with median value. Greater than 50% and 80%, here also create a separate flag create a separate flag, then replace with 1 else 0. Greater than 50% to 80%, create a separate flag, then replace with 1 else 0. I mean 0 means non-missing. If it is greater than 80%, if it is greater than 80% of missing values, straight away remove the variable. Straight away remove the variable. Okay. Here the thing is that numerical values. Numerical means continuous variable. In the continuous variable, if it is less than or equal to 10%, we need to replace the values with mean value. If it is in between 10 to 50%, we need to replace the value with median value. If it is greater than 50 and less than or equal to 80%, then create a separate flag wherever it is missing as 1 else 0. If it is greater than 80% of the missing values, straight away remove the variable. If it is greater than 80% of the missing value, straight away remove the variable from the model. Now, you may get a doubt. In our data, you may thousands of variables or hundreds of variables. How do we process for each and every variable? Don't we think, is it a really big task? Will it take a much time to do? For this, R has developed the one package called as Impute Missings. So wherever we have a missing, we need to impute the missing. So first we need to install Impute Missings. We need to install the Impute Missings package. So once we install, then we need to go for the library Impute Missings. So just by using the impute function, dataset 1 is equal to impute of dataset. Simple function, sir. Impute of dataset. So impute of dataset means it will take care about the impute the missing values. Impute function, it will take care about both numerical variables as well as categorical variables. Impute function, it will take care about both numerical variable as well as the categorical variable. So let's do a lab for this. Before we are going to discuss about the lab, do you guys have any questions about this? Any questions, sir? Is everyone is clear? Huh? Flag means creating a new variable wherever it is missing as 1, otherwise 0. Yes. Any questions, guys? Otherwise, shall I go with the lab? Okay. Let me go with the lab. So here clearly indicates voice attempt variable is the 1. if we are using the impute function, it will not take, it will not remove the any variables. Automatically it will impute the values only. First we need to install impute missings package, and then library impute missings. So already I impute the missing values. Any NA means, is there any, first before we are impute the missing values, we are checking. We have one function also called in the impute missing any NA. Any NA will tell us about, is there any missing values? Yes, there are the missing values in the data set. Here, what are the variables which are in the missing values? Here in this case, okay. Here in this case, what we are going to do, here let's say we have a missing values, right? We are treating the missing values. Unbilled data 1 is equal to impute of unbilled data. Simple. Unbilled data 1 is the, I am creating the new data set. The reason why we are creating the new data set, because maybe you are doing a wrong, someone says that don't use the impute function, go with the manual. So that is the reason you should not disturb your original data. So keep as a copy, create a new data set. So unbilled underscore data 1 is equal to impute of unbilled data. So automatically it is creating the unbilled data with the same number of values. Now we are to cross verification purpose. Again we are checking the newly created data set, does it having the any missing values or not? How do I check? Any NA of unbilled data 1. So false. That means it says that there is no missing values in the unbilled data set. It says there is no missing values in the unbilled data set. Clear? Huh? True. Now we are impute the missing values, right? Here we impute. Now first before we have taken the any NA unbilled data in 155 row. What we have taken? Any NA unbilled data. So after that it says as the true. But in 156 what we have done? We have created the new data set unbilled underscore data 1 is equal to impute of unbilled data. Impute of unbilled data is nothing but imputing the missing values in the unbilled data set. Again to cross verification purpose, what we have done? Again we check the any NA unbilled data 1. Unbilled data 1 is nothing but the one which you have created newly. So in that data set we check that is there any missing values? No, there is no missing values in the unbilled data 1. Next, yes, we're done with the missing values. Now let's go for the basic statistics. How do we calculate the mean in R? How do we calculate the median? Yeah, tell me, Srinivas.
Yeah, this impute function will do all these mean, mode, and all everything, or?
Yes, it will do all these things. The methods, the levels which we have discussed, right? Those things it will cover.
So it will calculate that greater than, less than or equal to 10, greater than 10 to 50, like that.
Yes.
Directly it will calculate, right?
Yes.
Oh, okay.
Now let's have a calculation about the basic stats. How do we calculate the mean value? How do we calculate the median value. How do we calculate the mode? As a maximum value, minimum value, range, variation, standard deviation, all these things. And percentages. How do we calculate the percentage value? Let's have a discussion about the same things here. Calculating the basic statistics. Here in the unbilled data one, I am using the unbilled data one. Here I am using the variable called as the value unbilled. I am using the variable called as the value unbilled. You can use the consumption also, which is the numerical variable. As an easy understanding purpose, I am using the value unbilled. First, we need to calculate the mean. What do you mean by mean? Mean is nothing but average. Sum of all the numbers divided by total number count is called as the mean. So simple, we have a function to calculate the average here. Mean of your data set name, unbilled data one, dollar, your value unbilled. So automatically it will give us the value on an average of the data set, which is 1176.268. So this is the average value. Now we would like to calculate the median value. How do we calculate the median? Median is nothing but middle point of the data. Median is nothing but 315. Median is nothing but 315. Median is nothing but 315. Next, mode. We directly we don't have any function to calculate the mode. So for that, what we need to do, we need to count how many times each and every value is repeating. So as per the mode, the definition of the mode is the number which is repeating more number of times. That is the meaning of the mode. So directly we don't have any function like mode in the R. So what we need to do, x is equal to table. Table function will give us the count how many times particular value is repeating. Here unbilled data 1 dollar value unbilled. Here table function will help us to give how many times particular value is repeating. So why I mentioned the x? So these are the values. So suppose to check the view is nothing but to check in the form of table format. So here the value is the 0. The where one is nothing but actual value. Frequency is nothing but count. 0 value in our data set which is repeating 645 times. 0.01 which is repeating 65 times. 0.03 which is repeating 37 times. Like that, each and every value how many times it is 0.41, 0.5, 1.1, like that we have. Now the number, we need to check what is the number which is repeating more number. Here after the freak we can see the like drop down buttons here wherever my cursor is. So double click on this. Here automatically. So this is the only the one record which is the median mode value. Here in this case the mode value is the number which is 0 which is repeating more number of times. So the mode for the value unbilled will be 0. Let me summarize it again. Directly in R, the definition of the mode is the number which is repeating more number of times. Directly we don't have any function like mode of like how we calculate the mean, median. Directly we don't have any function like mode. To get the mode, what we need to do by using the table function. What is the table function will does? Table function will give us how many times particular value is repeating or number of times it is counted. to get that values, what we are going to do, just we are assigning as a x as a temporary purpose. X is equal to table of your data set dollar variable name. So in this case, view of Excel, automatically it will get us know how many times particular value and count. Frequency is nothing but frequency, that is nothing but count. So how many times particular value is counting. So to get that point, what is going to happen, we need to do all these things. Just by using this freq, we will get to know which is the number repeating more number of times. That is how we can calculate the mode value. In our case, in the value unbilled data, the value which is repeating 0 as repeating 645 times, so we can consider 0 as the mode value. Is it clear, guys? So here next value will be variance, where variance means okay, before we are calculating the variance, let's calculate the max. Max is nothing but maximum value. Unbilled data 1 G dollar value unbilled. In the value unbilled, it will give us the 162,985.3. Min value, minimum value unbilled data 1 dollar value unbilled. Minimum value is the 0, maximum value will be 162,985.3. maximum value will be 168.162985. Then range is equal to range of unbilled data 1 dollar value unbilled. This is the value which is giving here. This is the first minimum value, this is the maximum value. The difference between the minimum value and maximum value will be the range. Is it exactly the correct? First 0 0 means minimum value it is giving, next value will be the max. Again we need to do the difference of maximum value minus minimum value, maximum value minus minimum value. Next will be variance. Where of unbilled data, where is nothing but variance, value unbilled. So automatically this is the variance value of the data. What do you mean by variance? How each and every individual value is varying or deviating from its mean value. How each and every individual data points is varying or deviating from its mean value. This is the nothing but variance. What do you mean by standard deviation? Square root of the variance is called as the standard deviation. SD means standard deviation. Unbilled data 1 dollar value unbilled. That is the variance here in this case 3291. 3291. This is the, of course we can use the square root of, again square root of whatever the variance value 1083 1277, exactly the same. Square root of the variance is exactly the, that is the what we got the variance value 10831277. Again I will apply the square root. SQRT is nothing but square root of value. Automatically it will remove the and it will give the value of the standard deviation. Okay, perfect. Now while we are any questions before we are going further? Any questions, guys, who are online? Okay. Now, before we are going further discussion, let's have a discussion about outliers. What do you mean by outliers? Or outliers means extreme values are called as outliers. In a business, let's say, let me give an example. In an organization, 50 members are working in an organization. In an organization, 50 members are working. 49 members' salary is less than 50,000 rupees per month. But one person, assume that CEO salary is more than 5 lakh per month. Now, the behavior of the CEO as well as behavior of the remaining 49 employees in terms of the salary, will it be the same or will it be the different? Definitely will it be the different. Maybe the common whom are getting the 50,000, they might come by bikes. Of course, some people might come by the car also, but 50 lakh people who are earning 5 lakh per month definitely need to come by the car. Company will provide the extra benefits compared to even suppose marketing people, they want to target the customer as a high income people. Will they target the 49 people or will they target the one person only? So while building the model, data should not have the any extreme values. Other name of extreme values are also called as the outliers. Simple terms, how do we say that? When we say that normal distribution curve, here this is the value mu minus sigma to mu plus sigma. This is the 68% of the total population. Mu minus 2 sigma to mu plus 2 sigma. This is 95% of the total population. Mu minus 3 sigma to mu plus 3 sigma, it is called as the 99.7% of the total data. Any data point which is not falling under mu minus 3 sigma to mu plus 3 sigma, those are called as the outliers. Any one way to find out the outliers are mu minus sigma to mu plus sigma, which consists of 68% of the total data. Mu minus 2 sigma to mu plus 2 sigma, which consists of 95% of the total data. Here 68% means, what does it mean? Total area under the curve, which is 100%. Out of that, first 68, let's say we have the 100 records. After that 68 record, of course automatically first it will sort the data. First 68% of the first 68 records, which is in the range in between mu minus sigma to mu plus sigma. Next 95% record, 95 record out of 100 records, first 95 records, which is in the range between mu minus 2 sigma to mu plus 2 sigma. 99.7, almost 0. less than 0.003, that those records which comes under the 99.7. so last record, the difference between if it is more, then we can say it is an outlier. But how do we calculate the outlier? This is the way. This is the one method. Other method to find out the outliers are box plot method. Before we are going to the next method, is there any doubts about this method? Hi. Uh, is there any doubts about the this one outlier find outs? Hello.
Nobody.
Okay. Okay. Next method is the box plot method. Box plot method is box plot. Box plot method is also called as 5-point number summary. Box plot method is also called as 5-point number box plot method is also called as the 5-point number summary. Those 5 points are minimum value. Second one is the 25th percentage. Third one is median value. Fourth is 75th percentage. Fifth one is maximum value. See here, how does the box plot looks like? This is the value which is the box. This is the value which is the minimum value. This point is the 25th percentage. This point is the median value. This is the 75th percentage. This is the maximum value. Maximum any data point which is far away from this line, any data point which is far away from line, this line, those are called as the any data point which is far away from this line, those are called as the outliers. Let me show you this. How do we draw the outliers in? How do we draw the outliers in R? How do we draw the outlier? But by using the box plot, we will not get how many outliers are there. By using the box plot, we will not get the how many count of outliers. Just it will tell us whether outliers are presented in the data or not. Let's say here, simple, we are using the box plot. Box plot unbilled data 1. For example, I am using the consumption variable. See here, my most of the data which is here, but one point is far away from these values. My most of the data is here thickness in the ground level. If it is the black line, under the black line we have the thick line. Above the thick line, the dots are there. Where some points are very near to the thick line and one point is far away from the thick line. It doesn't mean that only one record which is an outlier. No, it says that some of the values are far away from your data. So definitely in this consumption variable, you have an outliers are presented, right? Here it says that box plot will says that definitely there are the some values which are far away from your given data. It clearly indicates that there is a some value which is an outliers. But as I my experience, what I observed most of the cases, as I my experience which I observed most of the cases, if the line is like this, if the line is thick line, very thick line, then like this thick line and points, then definitely outliers. And if this box size is very high, box size like this, rectangular shape, more close, width of the box is very high. Width of the box is high if the width of the box size is high, then there is more probable chance to have an if the width of the box size is high, then there is a more probable chance to have an outliers. Rectangular. In some cases may look like this. Some cases may look like this, or some other cases may look like this. If it says that most of values are near to each other, here in this case it says that most of the values far away bit. If it looks like this, like a line like this, it says this. It says that most of the values are close to each other. Here in this case, most of the values are far away, but those are not the outliers. Far away, that doesn't mean that those are the outliers. Any questions, guys? Outliers, always we need to treat the median value only. Outliers, always, irrespective of the missing value percentage of outlier, we need to treat always the median value only. Irrespective of the outliers, we need to treat by using the median value only. Outliers we need to treat by using the median value. How do we treat? How do we get to know how many outliers? There is a function called quantile function. So quantile function, what will does? Quantile function, dataset name, unbilled data 1, dollar consumption. C means concatenate, 0 means 0%, 0.1 means 1%, 0.2 means 2%, 0.3 means 3%, 0.4 means 40%, 0.5 means 50%, 0.68 means 68%, 0.75 means 75%, 0.9 means 90%, 0.95 means 95%, 0.997 means 99.7%, 1%. These are the values. My 0% value is 0, 10% value also 0, 20% also 0. So that is the reason most of the values are 0, 0. That is the line. The line is very thick line. And here see, 99% value is 644,313, 6,44,000. But when you look into the 100% value is 36 lakhs, somewhere like that. Does it an outlier? There is a huge difference between the 644,313 versus 36,30,9949. Any value which is greater than 644,313, those records are called as an outliers. Is it clear, guys? Is it clear, Giri?
It could be not.
Huh?
Not clear. Not clear. I couldn't understand.
Could you
Here,
please repeat
Zero,
it again?
dark lines. If it is zero, it should be dark lines, correct? That is what you are trying to say.
no. Zero means most of the your first 20% of the data, which is zero. If you look into here, why it is the dark line? The reason is most of the values which falling in that range. Here in our data, if you look into here, first 20% of the data which is 0000 only. Out of 35,000, 20% means 7,000 records which is are the zeros only. So that is the reason this line, which is the zero line, the mean the points which is very close. Zero means 0, 0.1, all these things which consider the zero only. So this is the line which shows the dark line. Maybe sir, for example, let's say in other case, let's say 40 is the value. Assume that 0% value is the 40, 10% also value is the 40, 20% also 40. Then the dark line will be near 40 value. Wherever the number which is repeating more number of times, those values are called as the outliers. Here in this case, as we discussed, any data point which is greater than 99.7, those are called as the outliers. So here if you look into the difference between the 99.7 as well as the 100% value, there is a huge difference. Here the 99% value is 6 lakhs, 0.6 million, but whereas in the 100% value is the 36 million record. So in this case we can consider those values, any value which is greater than 644313, those values we can consider as an outliers. Clear? Giri, still is doubt?
No, we have more difference. So we have that big triangle. That is what you are saying, right?
Yes. So we need to treat the outliers by using the median value. How do we treat the outliers? So simply I am creating the one more new variable, unbilled data one dollar consumption underscore one is equal to if else unbilled data one dollar consumption value is greater than 644313. That is the 99.7 value, right? Any value which is greater than 99.7 value, those values we need to treat. With the, how do we treat? By using the median value, median of unbilled data one dollar consumption. If not, what we need to do? We need to replace with the actual value only. Unbilled data one this is how we will do. Now let's check the box plot again. Unbilled data $1 consumption 1, that is the newly created data set. See how your data looks like now. All the values are close to each other. None of the values are not far away. So it says that there is no outliers in our data set. Is it clear, guys?